Welcome back to Advanced Skills Learning. Latency in LLM systems is not just a performance issue. It is a product issue. Slow systems feel broken, even when they are technically correct. And most teams try to fix this by optimizing models or infrastructure. But the highest impact improvement often comes from a much simpler layer. Caching. Not basic caching, but intelligent, layered caching strategies designed specifically for LLM workflows. In real-world systems, users repeat patterns, the same questions, the same workflows, the same API calls, but your system treats every request as new. That means recomputing embeddings, rerunning retrieval, and regenerating responses. Each time, this is wasteful, not just in cost, but in latency. Without caching, your system is doing the same expensive work over and over again, even when the answer hasn't changed. Caching in LLM systems is not just storing responses. It is about capturing computation across multiple layers. You cache embeddings, retrieval results, and even final outputs. When a similar request comes in, the system checks if it has already solved something close enough. If yes, it reuses it. If not, it computes fresh results. The key idea is simple. Avoid recomputation whenever possible, but without degrading answer quality. Caching is not a single layer. It exists at multiple points in the pipeline. Input caching stores prompt or embedding results. Retrieval caching stores document sets for queries. Output caching stores final generated responses. Each layer reduces a different type of work, and combining them creates multiplicative gains. Most systems fail because they only cache outputs, ignoring the deeper layers where most latency actually happens. Embedding generation is often overlooked, but it adds latency and cost at scale. In enterprise systems, the same queries or documents appear repeatedly. By caching embeddings, you avoid recomputing vectors every time. This is especially powerful for chat histories, repeated prompts, and document ingestion pipelines. It is one of the easiest wins, and yet many systems completely ignore it. Retrieval is another expensive step. Vector search, hybrid search, filtering, re-ranking. All of it adds latency. But for many queries, the retrieved documents do not change frequently. So instead of rerunning search every time, you cache the top K results. When the same or similar query appears, you skip retrieval entirely. This dramatically reduces latency in systems with stable knowledge bases. Output caching gives the most visible performance improvement. Instead of calling the LLM again, you return a stored response instantly. But this comes with risk. If your data changes, cached answers may become outdated, or worse, incorrect. So output caching must be controlled carefully. It works best for deterministic queries, FAQs, and systems where answers do not change frequently. Quick check. 2 seconds. What is the most effective caching strategy? A. Only cache outputs. B. Cache multiple layers. C. Avoid caching. Keep your guess. The answer is B. Real gains come from layered caching, not just output caching. A critical decision in caching is how you match queries. Exact matching is simple but limited. It only works for identical inputs. Semantic matching is more powerful. It allows reuse across similar queries, but it introduces risk. Slight differences in intent can lead to incorrect reuse. The balance between exact and semantic matching is one of the most important design decisions in LLM caching systems. Caching introduces a classic problem: invalidation. When your data changes, your cached results may no longer be correct. This is especially critical in enterprise systems with dynamic data. If you don't invalidate properly, you risk serving outdated answers. And this is one of the hardest problems in distributed systems. Not generating answers, but knowing when to stop trusting them. To manage invalidation, systems use strategies like TTL and versioning. TTL ensures that cached entries expire after a fixed time. Versioning ties cache entries to data versions. When data updates, the cache is invalidated automatically. The most robust systems combine both. They use time-based expiration for safety and version-based invalidation for correctness. This balance ensures performance without sacrificing accuracy. Quick check. 2 seconds. What is the safest cache invalidation strategy? A. Never expire cache. B. TTL plus versioning. C. Only manual invalidation. Keep your guess. The answer is B. Combining TTL and versioning gives both safety and correctness. Caching is powerful, but not universal. It breaks in systems with highly dynamic or personalized queries. If every query is unique, cache hit rates drop. Worse, semantic caching may reuse incorrect results across users. This leads to subtle but dangerous errors. The key insight is simple. Do not force caching everywhere. Apply it selectively, where repetition and stability actually exist. Here are the key takeaways. Caching is one of the highest leverage optimizations in LLM systems. But only when done correctly. The biggest gains come from caching across layers, not just outputs. Always balance performance with correctness. And never underestimate cache invalidation. Because in real systems, speed without accuracy is not a win. It is a failure. Thanks for watching. If this helped you rethink your caching strategies, like the video and subscribe to Advanced Skills Learning for more GenAI explainers, practical architectures, and quick quizzes.